Use a system of equations to solve the following problem. A math department has a limited budget to buy equipment. One teacher purchased 5 tablets and 7 calculators for $3,675. Another teacher purchased 7 tablets and 3 calculators for $4,295. Find the cost of one tablet and the cost of one calculator. The cost of one tablet and the cost of one calculator are our unknown quantities, and so we're going to let x be equal to the cost of one tablet and y be equal to the cost of one calculator. And so let's clearly state what our variables represent. Because of the fact that we have 2 unknown quantities, that means that we're going to need to find 2 equations in order to find a unique solution. So in looking back through the given information, we see that one teacher purchased 5 tablets and 7 calculators, and the overall cost was $3,675. So one of our equations can come from this scenario. We have 5 times the cost of one tablet plus 7 times the cost of one calculator, and that total cost was $36.75. We can get a second equation from the fact that another teacher purchased 7 tablets and 3 calculators for $42.95. So 7 times the cost of one tablet plus 3 times the cost of one calculator is equal to $4,295. So now we have the 2 equations that we needed to find the solutions for x and y. Let's use elimination to solve this system of equations. In the elimination method, we're going to add these 2 equations together in such a way that one of the variables drops out. But in order to get my x terms to drop out, I'd need to multiply one of these equations by a fraction, and the same is true for the y variables. But I definitely don't want to introduce fractions, so instead of multiplying one equation by a constant quantity, I can actually multiply both equations by a constant and build both of them up so that one of the variables drops out. Let's work towards eliminating the x variable. And in order to do that, we'll multiply the top equation by 7 and the bottom equation by 5, but it needs to be a negative 5 so that I'll have a positive and a negative 35x. So let's distribute the 7 into the first equation, and I'll end up with positive 35x plus 49y. And 7 times 3675 is 25,725. Now let's multiply the negative 5 into the second equation, and we'll get negative 35x minus 15y, and 5 times 4295 is 21,475, but again that's negative. So now we're ready to combine like terms on both sides of these equations, and we see that the 35's cancel out. 49y minus 15y is going to be 34y positive, and combining the 2 right-hand sides we get 4,250. And now in order to solve for y, we'll divide both sides by 34 to get y is equal to 125, which means that the cost of a calculator is $125. Now let's use our y solution and plug that back into one of the original equations to figure out what the value of x should be. And neither one of these original equations is much easier than the other, so I'm just going to pick the top one. We'll have 5x plus 7 times what we found to be y, which was 125, is equal to 3675. 7 times 125 is 875, so let's subtract that from both sides. So we now have 5x is equal to 2800 over here on the right, and when we divide both sides by 5, we get that x is equal to 560, which means that 560 is the cost of one tablet, and again 125 was the cost of one calculator.